All right, in this chapter, we're going to work with algebraic fractions. We begin by working with factoring. I cannot emphasize enough how important it is to practice and build strong factoring skills. Factoring is going to be the foundation of this entire chapter. And this chapter, the material in this chapter is so important that we cover it again in Pre-Calc 2. Because we want to make sure that we have strong algebraic skills, that we are algebraically nimble, especially if you're thinking that you might at some point go on to take calculus. Having strong algebra skills is a huge predictor of success in calculus. So factoring means the same thing it meant when you learned how to factor back in grade school, right? Like if I want to factor the number 12, I can make a little factor tree. So 12 is 4 times 3. 4 is 2 times 2, so then we say 12 is 2 squared times 3. And there we factored it all the way down till it can't factor any further. In this case, we factored all the way down to primes. We're going to look at different scenarios, different types of factoring scenarios. The simplest is taking out a common factor. So if we look at an expression, say this one in part A, 6x minus 2y, and we say, you know what, both of those terms, 6x and 2y, they have a common factor of 2. Then what we're going to do is take out that common factor. Now we're not dividing, but we are taking out the 2, and then we open up a set of parentheses, and we say, all right, well, what do we multiply by 2 to get 6x? And that would be 3x. Then we bring down the minus, and what do we multiply by 2 to get 2y? And that's just y. And so there is the factored expression here. In the middle, you can see that we have a common factor of 2. We also have a common factor of x and a common factor of a. And so when you're taking out a common factor, you always want to take out the greatest common factor. All right? So we're going to take out everything that we can take out, everything that's common to all terms. In this case, that would be 2ax. And now we open up a set of parentheses and we say, well, what do we multiply by 2ax to get 4ax squared? Well, I need a factor of 2 to get me to 4. I don't need any a's because there's only an a to the first, and I took out an a. And then I need one factor of x to bring us up to x squared. I bring down the plus. What do I multiply by 2ax to get 2ax? Well, that's just 1. So there is the factored expression. You can always check your factorization if you just, distribute, multiply it out, and you should recover the original expression, and you'll see that that happens in these cases. So there's that factored expression. And then in part C, we have 3 terms, but it works the same way, right? We're just going to see what's common to all 3 terms. And if we look, let's see, at the constants, 6, 9, and 3, the common factor is 3. Now I've got a raised to different powers here. I've got x raised to different powers, and the rule is you take out the least power common to all. So that would be a cubed and x squared. And then we ask ourselves, well, what do I multiply by 3a cubed x squared to get 6a to the 5th x squared? Well, I need a factor of 2 to get me to 6. I need a factor of a squared to get me to a to the 5th, and then I don't need any x's. I bring down the minus. What do we multiply by 3a cubed x squared to get 9a cubed x cubed? Well, I need a factor of 3 to get me to 9. And I need a factor of x. Right? We don't need any a's. And then plus, bring down that plus. What do we multiply by 3a cubed x squared to get 3a cubed x squared? And that's 1. So there's that factored expression. At the end of factoring anything, I always just look at my factors and see, oh, could I take anything more out? Because that'll help me catch an error if I didn't take out the greatest common factor. If I didn't take out the greatest common factor, then I would notice another factor common to all 3 of those terms, and then I could just take that out, and so it would be like a 2-step process instead of just one. Our next scenario is how we factor the difference of 2 squares. So we begin with just a fact here. X squared minus y squared factors as x plus y, x minus y. Now, you don't have to take my word for that. We can multiply x minus y times x plus y And we can convince ourselves that this does in fact give us x squared minus y squared. So across the top, x times x is x squared, and then we have a minus xy. On the bottom, I have a positive xy, and then a minus y squared. We could see that the plus xy minus xy cancels, and then we end up with x squared minus y squared. So the first step in factoring a difference of squares is to recognize when you are looking at a difference of two squares. So x squared minus 16. X squared is obviously a perfect square. 16 is 4 squared. And then we know this is going to factor as x plus 4, x minus 4. The next one, 36x squared and 49y to the fourth, those are both perfect squares. So 36x squared is the square of 6x, and then minus 49y to the fourth is the square of 7y squared. And now we'll factor as a difference of squares 6x plus 7y squared, 6x minus 7y squared. And that's as far as we can go. Next, 20x squared minus 45. So if you're looking at this, you might be thinking, well, 20 and 45, those are not perfect squares. And you'd be right. The first thing I always look for if I'm in a factoring, if I'm trying to factor an expression is there a greatest factor I could take out? So I usually try to look for that first. In this case, we could take out a common factor of 5. And then we're left with 4x squared minus 9. And now, 4x squared minus 9, that is a difference of squares. 4x squared is the square of 2x, and 9 is, of course, 3 squared. And now we can factor this. And notice I'm bringing down the 5 with me as I go, right? So we don't lose any factors along the way. So 2x plus 3, 2x minus 3, times 5, of course. And there, this is factored all the way. So factoring can often be like a multiple step process. Maybe I don't have a difference of squares at first, but then eventually I do after I take out a common factor. And there'll even be other types of factoring that we're going to look at in a little bit in this section. Let's do one more of these difference of squares problems. X to the fourth minus y to the fourth. Now, that is a difference of squares. X to the fourth is the square of x squared. Y to the fourth is the square of y squared. So we can factor this as x squared plus y squared times x squared minus y squared. And then when you're done factoring, you always stop and you say, okay, can I factor any further? And this second factor here, that's another difference of squares. So we can factor that as a difference of squares. The sum of squares does not factor, so that stays as is. But this is x plus y, x minus y. So anytime you're doing a problem and it says factor this expression, they always mean factor it all the way. If you only factor it partly on a problem, on a quiz or a test, that's not going to be a 5, right? That's not going to be full credit. All right, factoring trinomials. This is the one that takes a little bit of sometimes guess and check, I would say. This whole process is basically kind of unfoiling, or that FOIL process in reverse, when we multiply two binomials. So I'm going to go up just in the margin here, and I'm just going to kind of think back. Let's remember, in Chapter 2, we would do a problem like this that would say, multiply the following. Say 2x minus 3 times x plus 1. And we have ways to do that. You could use the FOIL mnemonic, or, I'm a big fan of this, setting up this table, of course. right? We get 2x squared minus 3x up top. On the bottom, we got 2x and minus 3. We got our like terms along this diagonal, so we get 2x squared minus x minus 3. Okay, so that's what we would do in chapter 2, right? They'd give us a product and we'd multiply it out. What we're trying to do now is go backwards, right? In this chapter, we're going to be looking at problems where they give us this expression, 2x squared minus x minus 3, and they're going to say, all right, tell me what you had to multiply to get it. So these trinomials, right, where we have a squared term, an x term, and a constant, they basically always factor. If they factor at all, they factor in this way, where I open up a pair, two sets of parentheses, and then I just got to kind of figure out what goes in each pair. And we're going to do some examples to kind of just talk out how we think about this process. But first of all, I'm just going to say, if, the simplest type of factoring is going to happen when this trinomial is what we call monic, meaning this coefficient on x squared is 1. That's the simplest. And then even better, if the constant term is also prime, like it doesn't factor, that's even better. Because if this is going to factor, then the way I'm going to get an x squared is to get an x and an x. And the only way to get a 2 is to get a 2 and a 1 because it's prime. Now that's a positive 2, which means there's only 2 possible situations. I either have plus 2 plus 1 or minus 2 minus 1. I'm trying to make a decision that makes this middle term work out to plus 3x. And you can see that'll work if we have plus and plus. X plus 2, x plus 1. And then you always finish by doing a quick check on the outside-inside term. So that's a plus 2x. This is a plus x, and that does give us plus 3x. Because of how we choose the first 2 terms, right, the x and the 2 and the 1, we're pretty much guaranteed that these terms are going to work out fine, right? I mean, we put x and x so that we would get x squared. We put 2 and 1 so that we would get positive 2. It's that middle term that's the trickiest to make it work out. Now here, this is not a monic trinomial. The leading coefficient is 2, not 1, but we're doing pretty good still because it's primed. At least 2 is prime. That makes it easier. 2 is prime, also 5 is prime. So looking at that, that's going to make this a little bit simpler. I know that the only way I'm going to get 2x squared is to get 2x and x. I also know the only way I'm going to get a positive 5 is to have a 5 and a 1, either both positive or both negative. Now, because the middle term here is positive, I'm also confident that they're both going to be plus. Now, because it's not a 1x squared, because I had a 2x squared, it's actually going to matter which parentheses gets the 5 and which parentheses gets the 1. And so here's where sometimes you just have to do a little guess and check. So maybe I try, 2x plus 5 and x plus 1. So let's see, if I check this, we get a plus 5x on the inside terms, we get a plus 2x on the outside terms, and that would give us 7x, not 11x. So this actually does not work. So then we just try it again the other way. So maybe 2x plus 1, x plus 5, and here we have plus x, there we have plus 10x, and that gives us 11x, which works. All right. So let's try another one. These, the trinomials can be a little tricky just because they do involve some guess and check. But if possible, I always take out, if I notice a common factor, I take that out first. So notice here all the coefficients are even. So I'm going to take out a common factor of 2. And that leaves us with x squared plus 3x minus 4. And then I'll bring the 2 down, and then we'll just try to factor this trinomial, which will be easier because that's monic. Right now that's a coefficient of 1 on the x squared. Now 4 is not prime, which means I have some choices. It's either 4 and 1 or 2 and 2. But the other thing you'll notice is that it's a minus 4, and that means that one's going to be a plus and one's going to be a minus. Now we need to get a positive 3x. Now it's not going to be a plus 2 and a minus 2, because if that were the case, this would be a difference of squares. That would be how a difference of squares factors. So pretty sure we're looking at a 4 and a 1. To get a plus 3, we're going to need to use x plus 4 and x minus 1. And then we can just do a quick check here. Plus 4x minus x, which gives us a plus 3x. And that works. Now, if you didn't notice the difference of, if you didn't notice the common factor at first and you just jumped right into, unfoiling it, that can work. It'll maybe take a little bit more effort, a little bit more guess and check to make it work out. But for example, you could factor that as a 2x and an x and a minus 2 and a plus 4. That works. Now you'll notice that you're still not quite done factoring, because you can take a common factor out of that first one. So again, if your problem asks you to factor, that means factor all the way. And of course that's the same thing that we got there. All right, so our next scenario is where we factor by grouping. This is another form of like factoring out a common factor. But generally the common factor just has more than one term. And sometimes it's up to us to kind of rearrange terms to see what that common factor will be. So we're going to start with a simple one. This one really is just a common factor. We don't have to do any grouping ourselves. You'll notice that both of these terms has an x minus 1. What I'm doing is I'm subtracting this. In this expression, we are subtracting two products, right? H times x minus 1 minus 2 times x minus 1. We have that common factor, so we're going to take that out. And then what do we multiply by x minus 1 to get that first term? And that'll be an h. And then we bring down the minus. What do we multiply by x minus 1 to get the next term? And that would just be the 2. So that's how that factors. Sometimes we have to do a little organizing, a little more work to see the common factor that we can take out. So in this expression, 3x minus 3y plus ax minus ay, there's no common factor. It certainly doesn't look like an unfoiling situation, or at least it's not a trinomial like we had on the last page. But if I kind of group them, and I don't have to even rearrange the order of anything, I'm just going to kind of group them like this. I'm putting in these parentheses. Now notice that if I put in those parentheses, it does not change the meaning of the term, right? I'm not this plus here doesn't change, like how we would interpret that expression. So I'm grouping them that way, and now if I look at just the first pair, 3x minus 3y, I could take a 3 out of that. 3 times x minus y plus ax minus ay, I could take an a out of that, and we have x minus y. And now I have a common factor of x minus y, so we could take that out. And then what goes in the parentheses to give us this product, or this expression? Well, I need to start with a 3. I bring down the plus and end with an a. And these are, in fact, equal. And you could check, right? Again, all of these factoring problems you could check by doing the multiplication. If you work out this product, x minus y, 3 plus a, you get 3x minus 3y, ax minus ay, and that is exactly, those are the terms that we started with. Okay, let's try another one. Now, I'm going to group these terms as well. I'm going to have to be careful with signs, but I'm going to group this first pair of terms and then look at this other pair of terms here. Notice I'm including that minus. So I've got, in those first pair, I could take out an x, and then I get a squared minus 1. And then in the second pair, the pair that's highlighted in blue, I could take out a 3, but actually I'm going to take out a minus 3. And then what would have to go in those parentheses is an a squared minus 1. Again, if you distribute the minus 3, you'll see that you do recover the two terms that are highlighted in blue there. Now I have a common factor of a squared minus 1. So I'm going to take that out. And what goes in the set of parentheses? Well, I got to pick up this x term, or that x factor, bring down the minus, and then pick up the factor of 3. And now we're not quite done, right? We factored, but remember, factor means factor all the way. And a squared minus 1, that's a difference of squares. So a plus 1, a minus 1 times x minus 3. And that is as far as we can go. Sometimes you have to try a couple of things before you kind of see what works. You know, if I look at this, there's a couple ways I could look at it. I could see, you know, if I grouped it like this, I could say, oh, well, I could take out a factor of y here, and that would be y minus 4. And then I could say, oh, well, this one is a difference of squares, so that's 4 minus 5x, 4 plus 5x. But then notice I have not factored the whole expression, and there are no common factors. So this is not a factoring of that expression. And so when that happens, I'm going to just not get too discouraged. I'm going to say, all right, I'm going to try again. Maybe I need to look at this expression a different way. So I'm going to just erase this and start again. And so instead of separating it out as two pairs of terms, I'm actually going to look at that set of terms in the front, the 3 terms as one grouping, and then that minus 25x squared by itself. This we can unfoil. We could factor that. So that's, I need a y and a y. I need a, let's see, I need a positive 4 at the end. So they're both the same sign. The middle sign is a negative 4, so that's going to be a minus minus, and I think 2 and 2 is what works, right? That'll give us, if you do a quick check, minus 2y minus 2y, so that works. And then minus 25x squared. Now, of course, we're not done. We have not factored the original expression, but we're getting closer. I've got y minus 2 times y minus 2. That is, of course, the same as y minus 2 squared minus, and 25x squared. That's a perfect square. We've actually, I think, already acknowledged that when we tried this the first time around. It's the square of 5x. Now we could factor this as a difference of squares. And so, let's see, we take y minus 2 plus 5x, y minus 2 minus 5x, and there is as far as we can go. And you could check, right? Again, all of these factoring problems, you could check by doing the multiplication and seeing that you get the original expression back when you multiply it out. All right, we got one last scenario to look at, and that's factoring the sum and difference of cubes. So first of all, I'm just going to notice, I'm going to observe that we know how to factor the difference of squares. The sum of squares generally does not factor. But with cubes, both the sum and difference of cubes factors, and they factor in this way. Now, there's similarities to both of these. So first of all, they both have a small factor and then a big factor. right? 2 terms and then 3 terms, okay? The small factor kind of mirrors the original expression just without the cubes, right? So x cubed plus y cubed, that small factor is just x plus y. X cubed minus y cubed, that small factor is just x minus y. And then the big factor you form in the following way. You've got 3 terms. Each of those 3 terms you get by multiplying 2 things together. So an x and an x and a y, and a y and a y. Right? That's, in fact, and that's true for both of them. An x and an x and a y and a y. It is always ends with a plus, y squared. What's different is the middle term. And the sign of the middle term is always different from the sign of in your original expression. Right? So a sum of cubes has a minus xy. A difference of cubes has a plus xy term. It gets, with a little bit of practice, you kind of get used to how this factors. So x cubed plus 8. So the first step in factoring a sum or difference of cubes is to recognize when you're looking at a sum or difference of cubes, 8 is equal to 2 cubed. So I know I'm going to have a little factor, big factor. The first factor is going to be basically just this expression without the cubes, so x plus 2. In the big factor, I've got 3 terms. I'm going to get them all by multiplying 2 things together, an x and an x, so that's x squared, an x and a 2, so 2x, and then a 2 and a 2, or 2 squared. It's always plus here, and then this sign is always different from that sign, so that's a minus. So x plus 2 times x squared minus 2x plus 4. Let's try another one. X cubed minus 1. Of course, 1 is equal to 1 cubed. So that's already written as a difference of cubes. I'm going to have a little factor and a big factor. X minus 1. And then x and x is x squared. X times 1 is x. 1 times 1 is 1. Always ends with a plus. This sign always differs from that sign. So there's a plus x in the middle. Alright, next, 8 minus 27x cubed. 8 is 2 cubed. 27x cubed is the cube of 3x. So now that I've written it out this way, I think I'm ready to do the factoring. Little factor, big factor. The little factor is 2 minus 3x. Big factor, 2 times 2, or 4. 2 times 3x is 6x. 3x times 3x is 9x squared. Always ends with a plus. This sign always differs from that sign, so that's a plus 6x. Alright, let's try one more. Now, taking a look at this, we're not looking at a sum or difference of cubes here, but we could take out a common factor. 12 does go into 96. Also, we could see the a cubed is common. So we're going to take out a 12a cubed, and then what we're left with is 1 plus, and 96 divided by 12 is 8. So that would be 8b cubed. And now we're looking at a sum of cubes in those parentheses. So we got 1 cubed plus 2b cubed, and now we could factor it as such. Little factor, big factor, 1 plus 2b, and then 1 times 1, 1 times 2b, 2b times 2b, always ends with a plus, and the middle sign always differs from the original sign here, so that'll be a minus, and that's as far as we go. Alright, so do the practice, do all of the practice exercises. There's many exercises to do, The more you do, the faster you get at it. You want to really be comfortable with factoring. It will make the rest of this chapter easier to do.